Okay, we move on to Karl Pringle, GenXys, enabling precision prescribing with embedded pharmacogenomics at any point of care. And Karl is Chief Executive of GenXys, which is based from Vancouver, and is working across North America at the moment. Thanks very much, Karl.
So good afternoon, everybody. Thanks for inviting me to speak at the Spine. And I'm, as Munir said, I'm the Chief Executive of GenXys. GenXys is a software company. We specialize in precision prescribing software. That's also known as clinical decision support software with a bit of marketing dust sprinkled on there. Indeed, we are based in Vancouver. Our office is on the far side of those buildings, facing north towards the mountains. You may have heard of Whistler and not Vancouver. Wouldn't be surprised with that. We've got a big backyard to play in, but Vancouver has a few problems, just like every other major city. And Canada is a country similar to other countries, and one of those is adverse drug reactions is a top 5 cause of death. And, we've got a British export in our company. In fact, our founder, Professor Martin Dawes, who some of you may have heard of, he set up the Centre for Evidence-Based Medicine at Oxford University, but he had a deep passion in pharmacogenetics. And probably about 20 years ago, he thought, pharmacogenetics at some point in someone else's lifetime will be a test that's routinely done every baby at birth. And, I don't think we're too far off that, to be honest. In Canada, we've already started to explore that with our provincial governments as well as our federal governments. But the key challenge that he set himself, and we now set our GenXians, is how do we make pharmacogenetics usable at any point of care? By the way, the other problem that Vancouver has is a lack of talent. So if anybody fancies a job in Vancouver, come and see me afterwards. So about GenXys and our software, we do a variety of things, but it's all about helping the clinician at any point of care make the right prescribing choice. So the first thing we do is we are able to do the interpretation and translation of the pharmacogenetic data from the lab that it comes from. We are lab agnostic. We've been vetted and verified by Illumina, vetted and verified by Thermo Fisher, vetted and verified by Agena. We're going through the process at the moment with PacBio. No surprise, in the US in particular, most of our customers use either Agena qPCR technology or Agena Veridose technology. We can also bring in the translated and interpreted genetic and pharmacogenetic information from other sources as well. Then we have our clinical decision support software. And this is designed for any pharmacist or any clinician to use the pharmacogenetics within their environment. It doesn't matter whether they're in rural Indiana or a clinician in doing preoperative surgery work within Kaiser Permanente. Sorry about the US reference points there. That's where I do the majority of my work. The final tool we have is a population health analytics tool. And this is designed to enable clinicians to identify the right individuals to do pharmacogenetic testing on. And going back to the point we were talking about just a few minutes ago versus the first time it's reactive, and thereafter it's preemptive. Hopefully at some point it will just be preemptive. The other focus on this is doing it from a population base, so being able to take a large population and saying who are the most relevant people at this point in time for a pharmacogenetic test that's going to provide the best return on investment. So what we're doing is we are disrupting and transforming the centuries-old approach to prescribing, which is essentially one of trial and error. Try this. If it doesn't work or you develop a side effect, come back and we'll try something else. And we're moving that to an area which is this medication has been personalized with you. Nope, wait, we've got your pharmacogenetics. It's actually precise for you. You're going to get better. Now, what are all the data points that need to be factored into that decision-making process? It's drug-to-drug interactions. It's liver function, kidney function. Does the person have any other conditions that new medications are going to exacerbate? is there any other biophysical data that needs to be considered and any other lab tests? And now we also have the pharmacogenetics. So it's pretty complex. I refer to that as the ring of fire. It's impossible to expect a human today with their own computer to be able to go through all of these data points in a 7 to 9 minute consultation with their patient. It's ripe for computational power that's available today that we can have in the cloud that can be used at any point of care. So looking at some of the barriers of clinical adoption of pharmacogenetics, and let's put cost to one side, and let's put regulatory requirements to one side, and let's focus on the bits that are to do with the clinician. One is complexity in education. Part of the education is who are the right people that I should be doing pharmacogenetic testing for. A lot of clinicians don't know that, and in that 7 to 9 minute consultation, they're not thinking about it. The exceptions might be people that are, or clinicians that are focused in mental health, that are focused on using statins where clopidogrel is going to, or stents where clopidogrel is going to play a role. But then we have static reports, and static reports are another barrier to adoption because they're typically long, out of date the minute they're printed. And that kind of goes into the next one, which is they're siloed. You've got another point of siloed data that actually is pretty darn complex. And clinicians are not geneticists. So this complexity only exponentially increases each time you add in a different condition or a different disease. And again, that's a lot of information for someone to rattle through in such a short period of time. Point-in-time static reports. The average report is roughly 53 pages long. They come in a variety of shapes, colors, and detailed information. Some of them are very genetic focused, and a cardiologist is not a geneticist. That rural pharmacist is not a geneticist. They don't want to have to wade through genetic mumbo jumbo to get to the point of what is the right prescription for my patient. So what the problem is that you've got alert-driven, best practice alerts, and again, we talked about them being overridden, or ignored because of clinically validated reasons. But actually, what the clinicians really want is tell me the medications that are safe and effective to prescribe and at what dose. And by the way, if I don't agree with those safe and effective options that are presented to me, or I don't understand why my favorite medication is not there, then give me the ability to go and find out why. So coming back to all those data points on the right-hand side, it's all about interoperability, and it's absolutely critical to where we see the GenXys platform. We don't have to be the shining user interface that clinicians use. We've spoken to a number of the companies that have presented here today about being that prescribing engine under the hood that's integrated ultimately into the electronic health record, but may be integrated into the first data bank or Wolters Kluwer or Reed Elsevier solution for drug-to-drug interactions. We may be integrated into other lab systems to bring the lab results in. But the key thing is that we have broad interoperability across the care settings. And that means being integratable into the electronic health record systems, integratable into the pharmacy management systems, being integratable into the lab systems. As I said, we are lab agnostic. And actually in the US marketplace, our biggest customer source is not the health systems directly, because that is a pretty long and protracted sales process, but it's actually with the lab companies that already have the contracts to deliver the pharmacogenetic test to their customers, because their customers, the health systems, are saying, you keep giving us these 50-page reports, but our clinicians hate them. They don't know how to use them. We want something that's integratable. So by us licensing our software to the labs and them produce or data shuttling the information through our software to the clinicians is enabling the labs to volumize their business. So we've got 3 applications in our suite: TreatGX, ReviewGX. Those are the 2 clinical-facing applications. All of our solutions are real-time, multifactorial, and they're condition-based. Condition-based meaning we start from the point where a clinician starts from, which is the provisional diagnosis. And we have the ability to have the pharmacogenetics embedded. And I say we have the ability because it may be that clinicians aren't yet using pharmacogenetics, but they might be in the future. So if you have the same prescribing engine giving them the advice and the guidance on the right medications with or without the pharmacogenetics, then they don't have to learn two separated systems. So just to look at TreatGX super briefly, we currently cover 46 of the most commonly seen conditions, the big three buckets, no surprise: mental health, chronic pain, cardiovascular. The punchline here is that it can serve up 40,000 different prescribing options. And I've got a short demo in a second to show you. ReviewGX is designed for pharmacists. It is a medication review automation tool, and it will give pharmacists an insight into switch options for medications, augmentation options, dose adjustments, and deprescribing. And again, this can include or not include the pharmacogenetic data, just as it will include or has the option to not include liver function or kidney function. The point here is that it gives an objective dialogue between the pharmacist and the prescriber about why changes might be suitable for polypharmacy patients. And this is exactly who it's designed for. In the US, it's designed for patients that are on 5 or more medications, and a medication review typically manually will take hours to do thoroughly, let alone with the pharmacogenetic information in there as well. That's now reduced to minutes. Then the final tool is Identify PGX, which I talked about being the population risk stratification tool. We've modeled it up to a cohort of 1 million patients. It will look at the propensity of pharmacogenetic relevancy for different patients based on different medications. It also can include liver and kidney function and all those other data points I talked about, depending on where the data is coming from. So typically we see this with insurance companies where they say, hey, we've got 1 million patients, we've got their data record, we've got their claims data, we've got the cost of the medications. So part of the output of Identify PGX, if the data allows it, is a guidance on the return on investment of doing pharmacogenetics for different stratified groups of patients. So I thought it would be remiss of me, since we're here and it's all about clinical decision support, I didn't want you to think that this was something in the making that was, a vision in my mind, but actually our team has been hard at work over the past number of years developing something, TreatGX, that's actually out in market and actively being used. So I'm going to sit down while this plays, because otherwise I end up feeling a bit awkward staring at you, staring at the screens.
Welcome. In this short video, I'll demonstrate how to navigate the GenXys TreatGX decision support software. The TreatGX module can be launched from a number of different places in the EHR. Once it's launched, you'll have the chance to review and confirm what patient data is synced into TreatGX. Please make sure you review this information carefully. Let's look at some basic screen navigation. When TreatGX launches, you'll see this initial screen for the patient that you're working with. The patient name is found here on the upper left. On the left is the conditions list. Some may have been imported from the EHR, and you can add additional ones using this button at the bottom. When you're working with a condition for the first time, you may see sections highlighted with red boxes. This means that there's information that needs to be filled out before going further. Even if there isn't a red box, it's important to review each section to make sure that the information used is accurate for your patient. The middle column here has questions arranged with condition-specific and chronic conditions at the top, lab values, and finally drug contraindications that are relevant for the drugs used in the condition you're working with. Once all the required information has been filled out, press Generate Medication Options. The right-hand column will display drug options for this patient, generally ordered from preferred treatments to second line, third line, and so on. Any genetic information is tagged with this icon here. And note that the TreatGX software gives pharmacogenetic information even if the patient has not had genetic testing done and their metabolizer status is unknown. In this example, you can see that there's a risk of adverse events associated with certain CYP2C9 phenotypes. If there are any drug interactions with the medication the patient is already taking, this information is listed below each displayed drug. Interactions are marked as major, moderate, or minor, and you can expand each to get detailed information. let's look at changing information in the profile view. At any time, you can access the patient's main profile page and edit or add information like allergies and intolerances, medications, or lab values. Press the menu icon on the upper left. You can jump directly to the profile section or start from the top. Let's add a hepatic impairment here. I'm going to check off severe hepatic impairment or a Child-Pugh C score, and then I'm going to press save here on the bottom right. A green bar will let you know that the profile has been updated and the information has been saved. Now select back to go back to the TreatGX software. Press generate options again to see the drug list for this added information. Hepatic dosing will now be added for any relevant drugs, and if we scroll to the bottom here, you can see any medications that have been excluded because of contraindications. Here we can see that NSAIDs have been excluded because of severe hepatic impairment. Now let's look at changing values in this middle column here. You can also easily change any value in the middle column on the fly while using the software. For this instance, we can change the hepatic function right from the screen and set it back to no liver disease. If we press generate options again, you'll see that the drug list has changed back to reflect that. NSAIDs have been added back to the medication list now that hepatic function has been reset to normal. You can also add conditions at any time from the screen. By pressing this Add Condition button on the bottom left, you can search a list of supported conditions for TreatGX. We're going to select anxiety disorder here. As you can see, it appears in the left-hand column, again with red boxes to show that more information is needed to go further. If we click on this condition, the middle column changes to reflect that different questions are needed for this condition, in this case, anxiety. Again, please review and complete all sections to make sure patient information is accurate. By pressing Generate Medication Options, you get a new set of medications offered for anxiety this time instead of gout. But at any time, you can flip between conditions as well. Here we can see that gout medications are showing on the right-hand side, and if we flip back to anxiety, we can see the anxiety medications show. Now let's look at some advanced functions. TreatGX also has a number of conditions that support advanced functions. Here I'm going to demonstrate depression. We're given the option to initiate, switch, or augment depression treatment. Medication options are generated on the right-hand side as normal, with specific dosing, genetic information, and any other details. I'm going to draw your attention to the middle column again, because in this condition, you have the option to sort antidepressants by side effect profile. For instance, if we select sort by sexual dysfunction and regenerate the medication options, the order in which the medications are listed has changed. Instead of SSRIs at the top, we now see bupropion and mirtazapine listed first, and below that, the SSRIs themselves are sorted with the least risk of sexual dysfunction to most. You can do this sorting with a number of different side effects, and the list will reorder based on your choice each time. Other conditions support filtering or similar functions. Please feel free to explore the different functions.
It wasn't all about pharmacogenetics, because pharmacogenetics is good, but it's not good enough. It is just one piece of the puzzle, just as liver function and kidney function and all those other data points that are there. The idea behind our solution is that we're abstracting the science away from the clinicians. They don't have to be a geneticist to understand what the right medications are to prescribe. The other thing I'll say here is that that was a view looking into the GenXys platform being contextually launched from the EHR. In most settings, the clinicians aren't using our application. Our application is hidden under the hood of their EHR system. It's integrated into their drug database system, and everything that they're interacting with is coming straight through their electronic health record system. And that kind of leads me on to this, which is the data flow and the optionality around it. So I said we were lab agnostic. We integrate into the labs. We pull the genetic data from there into the GenXys platform where we do the interpretation and the translation. We then integrate into the EHR, the pharmacy management system, the claims management system. There's a push and a pull model depending on what the customer requirements are, and the information is displayed in real time to the clinicians. I talked about the fact that we're agnostic, and the data sync is something that we're working on because, the discussion that came up this morning was, well, what about if I go to my cardiologist that doesn't have access to the same system that my GP has? So there's quite a quite a lot of intricacies in there. One of the models that we definitely have is a patient owning their own pharmacogenetic data, and they can flash up a QR code, for example, wherever they may be, and they've essentially walking around with a biolocker. That is not something that is in market today, but we are building that capability in preparation for some of the regulatory changes that will come as healthcare is and ownership is democratized to the patient. So looking a bit more into the future, what are some of the other things that we're working on in the short term and due to be launched pretty soon is for our customers to self-select which pharmacogenetic guidelines they want to use. Do they want to use CPEC or do they want to use the Dutch working group? The other is we're working on drug-drug gene modeling. Enterprise reporting and the dynamic dashboard are very much intertwined, and that's to enable large organizations that are now working in population health and rolling out pharmacogenetics to either work towards preset KPIs or to be able to do some on-the-fly ROI modeling about how many patients have our clinicians utilized pharmacogenetics on, how many times have medications been guided, what is the treatment outcome being for those patients? So the summary is that, I think everyone here totally agrees and believes, and most countries now are that pharmacogenetics is here to stay, and it's got real relevance in terms of positive patient outcomes. Just in support of that, by the way, we've been very involved in some of the legislative work in the US, working with congressional offices on legislation such as the Right Drug Dose Now Act. We're also starting to see really strong tailwinds in terms of litigation. Sometimes, unfortunately, in the US, it takes a good old lawsuit to see some change. We've seen one that was nearly $1 billion to do with the state of Hawaii and clopidogrel. And we're also increasingly seeing smaller malpractice suits where pharmacogenetic information wasn't used appropriately. So there are high adoption barriers. I think everyone is now kind of coming to a consensus of what those are. The good news is that solutions exist that are proven that eradicate those barriers. And really, to make it work, the solution has to be real time, it's got to be interoperable, and bring all the different stakeholders in, from the originating lab, identifying the patients for the clinicians that would be suitable for pharmacogenetic testing, and then bringing pharmacogenetics into the prescribing output, along with all the other variables that have to be considered. It can't be a data point in abstraction and in isolation. So I'll leave it there.
Thanks so much, Karl. Please, Andy.
Can you hear me? Yeah. Andrew Bate, GSK. I work in safety, so thank you hugely for talking about adverse drug reactions, because for me, it's one of the subjects I was saying to Munir earlier, we don't talk about it enough. The amount of cost associated with adverse drug reactions is enormous. I love the fact you talked about interoperability, and I think that's something we need to do more and more of. I mean, I'm endlessly seeing dashboards that aren't linking to other systems. I think the US is fantastic in terms of, and Canada in terms of C-Node, Sentinel, linking across different healthcare systems, primary, specialty, and others. And I think there's a lot we can learn in this country from that. Although there's been great advances in the last couple of years in particular, I'm thinking post-COVID. So my question is, in terms of a learning healthcare system, are you able to, how can you learn in terms of unexpected outcomes, behaviours, and I'm particularly thinking in my area, pharmacovigilance, unexpected adverse drug reactions. Do you have any capability for finding the new emerging issues that we don't know about yet?
Yeah, so we don't have any capability in that, and part of the reason is that we are not driven by AI or machine learning today. And there's a few reasons for that. One is resource constraints, the second is regulatory. As soon as you go into the dark side of AI and machine learning, you get into a whole world of hurt with the FDA. and also one of credibility. You know, going to clinicians and saying, "Hey, we've got a black box that's going to give you some guidance in terms of your medications," they're going to get a little suspicious. So for us, we thought the best way to start is by transparent algorithms, and those algorithms can be looked at by the FDA and clinicians. We reference we keep a log of every single reference we use, of which currently we're up to about 3,600. But we do have plans to embed AI and machine learning in the future, which will be able to track exactly and keep store of exactly those unforeseen events so that they can be made use of. The other piece where AI and machine learning will play a role is in giving information to the clinicians, whether they want it or not, perhaps, which is 98% of your peers that saw a patient just like this one prescribed this medication X amount of the time.
Hi, thank you for a great presentation. I wanted to pick up on the point from the colleague from GSK around interoperability. You mentioned a couple of times that your platform's agnostic. So I'd love to learn a little bit more about what data standards you use to create your platform. Are you using HL7v2, FHIR? Do you have an open data model in which you store your data? And how does the integration work across the health system? The reason I'm asking that is because within the UK setting, of course, we've got a national health service, and what we want to try to think about is what standards we can put in place so we can implement pharmacogenomics at scale, an opportunity that we perhaps have in the NHS, which is perhaps unique compared to other health systems.
Yeah. So one of the benefits of a fragmented health service in the US is interoperability is super important, because everywhere you go to is different systems. And it's not dissimilar in Canada, actually. And Canada, in a lot of respects, is a lot more attuned to the NHS. We've got a single provider kind of system, but still, from a technological perspective underneath that, we're very fragmented. So just from a coding perspective, SNOMED and LOINC codes we use. And then from a standards, so FHIR standards we support. We operate in Microsoft Azure cloud environments. So every jurisdiction that we go into, we have to instantiate our software into that jurisdiction, both to comply with the regulatory requirements, but also because we have a degree of localization to do. So when our instantiation in Canada, for example, uses the Canadian formulary of medicines, the dosages, and any specific clinical guidelines. In the US, we've had to adapt it to the FDA and their dosing, their formulary, and we'll do the same with the UK.
Thank you very much, Karl. So where is it being used at the moment?
Canada, the US, Singapore, and we've just signed our first agreement here in the UK.
But how many within Canada? How many within the US?
So in terms of patient lives, we're up to about 70,000, and that equates to about 50,000 clinicians. In terms of lab companies, we're talking about 12 different pharmacogenetic lab companies, regional ones, national ones.
Okay. Great. Thank you very much for that. Thank you.